Well, good evening or good morning or good afternoon, whatever is appropriate to you in your time zone. My name's Nigel Brown, and I'm going to talk about designer benzodiazepines and pregabalin, and they seem to be coming a lethal combination together. So what I thought I'd do is first start with some statistics to give you an idea of the problem that we've got in the northeast of England. Then some of the benzodiazepine types that we're finding, and then moving on into the benzodiazepine receptor and how that's is important for the effects that these drugs have. And then changing tracks slightly into pregabalin and indeed gabapentin, principally their action with opiates, but is this also affecting the benzodiazepines as well? And then at the end, some methodological issues, and this is particularly for a local hospital. Whilst yes, we are a toxicology lab, we're attached to a district general hospital rather than a central teaching hospital with a university backup, and that brings about particular problems but also some advantages. So here's the statistics. These are the drugs found at post-mortem this past year, and as you can see, paracetamol is the most common drug, probably because it's widespread use, but also it's in the lots of the drug substances. Next most common are the opioids and the opiates, that's your morphines, heroines, tramadols and the like. Then antidepressants. This is all the drugs we found at post-mortem, so it's not just drug users' deaths, it's just anything that we get in. My database isn't good enough to be able to pick out the drug users. And as you can see, the next most common class are pregabalin and gabapentin, and we pretty well exclusively see those in drug-related deaths. Then below pregabalin and gabapentin, there's cocaine, then diazepam, which is the most popular of the benzodiazepines, and so on down the line. I've included zopiclone because that's a benzodiazepine-like drug, but and is very popular, particularly in one part of the region. And then moving down, I'll come to why promethazine is highlighted in a little while. And the only other thing that I want to point out is ecstasy. The suggestions, particularly from intelligence, that there's a large amount of ecstasy in the region, but we don't see much of it at post-mortem at all. And also, we don't see much of it in screening the urines from drug recovery services. The clinicians in the area are getting quite concerned. There's a ticking time bomb of ecstasy users who are slowly developing comorbidities, and in 5-10 years' time, they're going to be banging on the door of the recovery services with long-term issues due to the continued use. So, this slide gives you an idea of the benzodiazepine types we've been picking up. If you look at the top graph, that nice sort of crimsony red colour is your diazepam, so pretty constant throughout. But if you look at around about the third quarter of 2018, we suddenly start getting an increased number of the benzodiazepines. Okay, and yes, we had our QTOF was installed in the fourth quarter of 2017, so it might be related to that. But having talked to public health in the Teesside area, which has got that nice blue circle in it, which is where the benzodiazepine problem is concentrated, that's very intelligent as well. They started hitting the streets in the second half of 2018. We're based up in Northumberland, which is north of Newcastle, where the red circle is, and we don't see nearly so many of these benzodiazepines. It seems to be a Teesside problem. The bottom graph shows you the illicit benzodiazepines that are appearing. Alprazolam, or alprazolam, depending how you pronounce it, was the first one really to appear in big numbers. That's died away now, and flualprazolam, flubromazolam have taken over. Atizolam seems to be there quite a lot, and I'll come to that one again in a few minutes with a nice couple of pictures. We've also added in promethazine, and I'll say why to that in a few minutes in the next slide or two. So, this is why we got promethazine in there. We were sent a Xanax tablet to analyse by public health, and didn't contain any benzodiazepine at all. It contained some amantadine, cyproheptadine, and promethazine. A rather strange combination, but it ties in reports from the European Monitoring Centre for Drugs and Drug Addiction that this was also being found in cases from Spain and indeed Switzerland. So it's clearly there is a reason why people are using this combination. So, additional factors we found to be very useful in our, finding these drugs. We've got very good communication with one of the public health departments in the region. We also take part in the Regional Drugs-Related Deaths Group, where we are able to swap intelligence and information with the police, recovery services, clinicians, public health, and so on. It keeps us up to date with new drugs that are appearing in the scene, and really without this we'd be so much less successful. We also offer a clinical service. We're primarily a clinical laboratory, not a forensic one. So what we find in the dead informs what we should be looking for in the living, and vice versa. Because yes, it's interesting to find these drugs, but really what we want to do is to use the information to inform the clinical service of what's happening, so they can get the warnings out to the users that there's a strong batch of whatever out there. So, moving on to the benzodiazepine structures. I've taken this picture from a very good book edited by Hans Maurer and Simon Brandt, and I really do recommend it. It goes through all the different classes of the novel psychoactives. Here's your typical benzodiazepine structure, just above, and this is basically diazepam. But you can see you can add groups or here they're on the molecule which will affect its activity quite widely. Towards the top of the screen there, you've got the structure of a triazo derivative benzodiazepine, so like alprazolam. And again, these tend to have higher activities, and again, you can modify the activities by all these different groups. So as you can see from the basic structure, you've got a large number of different molecules that you can make. So, even more annoying is that these benzodiazepines have been synthesized using information on the patent applications or in the literature. So, for example, you've got this paper telling you how to make the things. Annoyingly, you don't even have to pay for the PDF when you click on the link. It's open access, so anybody can get to it. Some drugs like fenazepam or tizolam are prescribed drugs in other countries. We've also seen drugs purporting to be temazepam and some fairly good fakes, both temazepam and diazepam, but these actually contain the more potent benzodiazepines. We haven't tried to work out how much drug there is per tablet, so it may be that the strength isn't that much stronger, but some of these newer benzodiazepines have some quite nasty, potent effects that you wouldn't get from a temazepam tablet of the same strength. This slide attempts to give you an idea of the strength of different benzodiazepines. Typically, you work out your strength either by a rodent model, say a paw pressure test or a tail flick test, or you're doing it with receptor binding and tissue culture. Very difficult to translate that at times into what the effect would be on your average human being. Now, picking up diazepam, we can all do it nice and easily. There's metabolite CRMs, that's certified reference material for the metabolites. They're widely available, and it's easy to tune up your tandem mass spectrometer. Alprazolam, fair bit stronger, 20% of the doses in urine as a parent drug. So again, you can pick that up nice and easily. Tizolam, you've got a metabolite, alpha hydroxy metabolite, which has got a similar or possibly actually twice as long half-life. And really, we've noticed that we only really pick this up in urine using the tandems with a hydroxy metabolite. The parent drug isn't really in the urine. Alprazolam, well, metabolism is probably glucuronidation and hydroxylation, but the trouble is because this drug is quite new, there isn't that much information out there as to what the metabolism is across the population. Yes, you can do a study in one or two, say, fatalities or patients you know have taken the drug, or you can get data from tissue culture, but you can't get that broad data you would get from a large population to get an idea of what the best metabolite is to target detection for that drug. There's also only a certified reference material currently available for the parent drug. Flubromazolam, similar position. I've included flubrorazepam because we had 2 cases involving this drug several years ago now. This is quite an issue with this drug. Very long half-life. Tmax is about 7 hours, and it takes a couple of hours for the effects to kick in. The danger is, with this long lag time, is that the person taking the drug thinks it's actually not very good drugs. They'll have another tablet, and then it kicks in, and then it's, of course, it's too late. And I've included Zopiclone because it's so widely used, binds the same receptor, and this is easy to pick up. The metabolite CRMs are available, and it's easy to pick up. Something else that you need to consider when you get in these drugs is the effects they have. So this is from a paper by a group in Scandinavia, where they were looking at the users' responses to using fludrocortisone. Okay, now you can see why a user would want heavy hypnotic or sedative effects, but there's issues about tolerance. Tolerance develops rapidly, and the withdrawal is actually often quite severe and long-lasting. Some are reporting euphoria and intense well-being, so folk might want that, but there's been serious incidents of users have been admitted to hospital, needing acute psychiatric treatment, or taken or arrested. So these drugs aren't nice and safe, and very often the drug companies started developing, they've seen the side effects and they've stopped work on them. And this gives you an idea of Etizolam, which is probably the most common of the illicit benzos that we're seeing at the moment. This comes from the local press, and the police busted basically a factory where they're producing pills in industrial quantities. They've got a cement mixer, okay, for mixing the stuff together, and vast numbers of Etizolam tablets being churned out there for sale in the local area. And this actually was in the Sunderland area, I think, which is halfway between Teesside and ourselves up in Northumberland. Okay. So, to summarise, benzodiazepines, large number of possible molecules. The detection patterns are constantly changing and they're variable across our patch. So we can't apply what we find down on Teesside to what to look for up in Northumberland or in Newcastle upon Tyne. The metabolism of the newer drugs is unknown, so it's not clear what to look for in the clinical urine samples. And of course, for clinical work, if they're being tested in a clinic using one of the instant pots, that's the treatment, the pots they use in a clinic, will these actually pick up the newer types? So with the newer benzodiazepines, are they actually being used to get around the drug testing? So, benzodiazepines themselves, they bind to the GABA-A receptor. And gamma-aminobutyric acid, is the main inhibitory neurotransmitter in the CNS. It's a very big receptor, and this is a picture I've taken from the reference there, you can see. And what happens is GABA binds, the channel opens, chloride ions go into the cell, and it makes it less likely to fire an impulse. This receptor is quite a complex one. You've got site to bind benzodiazepines, probably ethanol, steroids, neurosteroids, and so on, as you can see from the picture. So it's a very complex receptor. Adding to its complexity is there's then the receptors actually acting in two different ways. You've got the traditional sort of receptor on the postsynaptic membrane, so responding to release of transmitter from the nerve cell downstream. But you've also got the same receptor in the membrane away from the synapse, and these seem to confer a longer term inhibition. It's a mistake to think of nerve transmission as just simple on-off. It's actually much more subtle than that, and there's lots of modulation and variation depending on receptor types, where it is, what other factors you've got interacting. The GABA receptor itself has got 5 subunits formed around a central pore. And if you look at that little list there's a huge range of different variants that are known. Okay, so there's no such thing as a GABA-A receptor that will do exactly the same no matter where it is in the brain. Typically, the major form of the brain is alpha-1 beta-2 gamma-2. Okay, but you can also further modify the activity of these receptors by phosphorylation, and there's various endogenous compounds. There's the neurosteroids, which are just derivatives of steroids but in the general circulation. 2-arachidonyl glycerol, which is an endocannabinoid that interacts with our cannabinoid receptors. And interestingly, no one has yet found the natural ligand for the benzodiazepine binding site. So it may be serendipitous, but there may be yet another neuromodulator waiting to be discovered. Right. So these isoforms are going to have different specificities for benzodiazepines and indeed sopicolone binding. So can we actually therefore directly compare the effects of any new benzodiazepine directly to diazepam, which is what I tend to do? I sort of say it's stronger, therefore it will have a more powerful effect. But is that strictly true? We just obviously don't know. So let's switch tack now to gabapentin and pregabalin. These would actually develop to be GABA analogues, so they were meant to interact with the GABA receptor. But they're transported across the blood-brain barrier by the system L transporters, which transports the neutral amino acids, so like valine, leucine, and isoleucine. And gabapentin and pregabalin actually bind to voltage-gated calcium channels, and this appears to reduce neurotransmitter release. Gabapentin and pregabalin were, they were touted as being anti-epileptics, and that probably is the basis of this anti-seizure activity. And of course, the binding, therefore, may be affected by these amino acids, which also bind to this voltage-gated calcium channel. So here's the structure. And as you can see, gabapentin and pregabalin structure there, you can see why they're GABA analogues. But actually what they need is that hydrophobic area for the receptor binding, and also the transport via the amino acid transport system. So the interaction between pregabalin, gabapentin, and the opioids was spotted first, and this appears to be more important, but I'm going to take you on as to why it might be important with the benzodiazepines. Paper came out in PLOS Medicine a few years ago now, and this was a population-based study from Toronto, and they were noting that folk taking opioids and gabapentin were at a higher risk of death compared to those just taking the opioids. But it could, of course, be that the folk who are needing both drugs are simply just more ill and they got more pain, and so therefore at a high risk of death anyway. But then a further study appeared from the UK, and this was looking at deaths involving heroin and the like, and gabapentin. This group here, they noted the gabapentinoid prescriptions rising by a ridiculous rate each year. Okay, massive increase in the prescription of these drugs, and the increase in deaths involving these drugs, of course, parallel this. And I have a nice graph that I've just taken from the paper, and as you can see, that nice red line is the gabapentinoid prescriptions, and then underneath you've got the two figures showing the increase in deaths. And again, same data, but produced as a logarithmic scale to give you a nice straight line. But there's some issues with this. They quote 137 deaths in 2015. But we ourselves, and indeed quite a few other toxicology labs, particularly the NHS ones, didn't really look for pregabalin and gabapentin till about 2015. We found in 232 postmortems from 2016, though it's actually 2019, not the present, but 2019, out of about 1,200 cases in total. In the UK, statistics regarding drug deaths are actually quite poor, and it really depends on what the coroner states the cause of death. So yes, pregabalin may well be involved, but the coroner may say, well, actually it's the heroin that, in my opinion, did it, or it was something else. So, but again, looking back in the literature with pregabalin, the preclinical studies suggested interaction with the GABA and the glutamate systems, which indicate there was abuse potential. And in also clinical studies of pregabalin, as it was being introduced, reported euphoria as a common side effect. So it's not really that surprising that it's being widely abused. In the UK, the MHRA, that's the Medicines and Health Regulatory Agency, they've recently issued a warning that pregabalin is linked to respiratory depression. And this Linden paper with the data on the deaths, they did some work in mice showing that pregabalin reduces respiration rate. It's not blocked by naloxone. The effect is still apparent in morphine-tolerant mice, so it seems to be working by a different pathway. But more worryingly, if you give morphine and pregabalin to morphine-tolerant mice, you get this significantly reduced respiration. And they're proposing and suggesting that actually pregabalin might actually be reducing morphine tolerance. And then another study looking at pain response in rodents. And so as you can see from this graph, morphine and gabapentin together, big response. Morphine by itself, much lower response, but gabapentin by itself doesn't really have much effect on the pain, but it really does amplify the morphine response to pain. So, is there a benzodiazepine interaction? It would seem to make sense that there is. The fatalities involving these designer benzos are actually usually multi-drug fatalities. I can't think of one that hasn't been a cocktail of drugs there. So ascribing the fatality of one particular drug is therefore actually impossible. You can't say, well, the benzodiazepine did it or the pregabalin did it. So is there an interaction between the benzos and pregabalin, gabapentin? I think there probably is, but I've got no data to back it up. And at the moment, there doesn't appear to be anything currently in the literature. But of course, as we all know, it takes some time for data to get from the bench into the literature. It can be a year, year and a half, depending on the journal. So something else to bear in mind, of course, of gabapentin, and indeed pregabalin, is both drugs are cleared by the kidneys. They aren't really metabolized to any extent at all. And a little while ago, we had this case where severe renal failure, creatinine in the vitreous fluid is over 800 micromoles per litre. That's severe renal dysfunction. So were the high levels of gabapentin, because they were high, were they due to poor renal function? But a particular character was found surrounded by empty medication packets and got increased codeine and zopiclone, but also had a cracking diabetic ketoacidosis. So you may be picking up this interaction between gabapentinoids and zopiclone and or codeine without actually needing to take the excess levels of drugs that you would see in abuse for abuse. So in this final little section, I want to sort of chat through some laboratory issues, really to sort of get us thinking about how we should be picking these drugs up. It's sort of confession therapy time, really. Clinical labs often screen for the most common drugs, which are generally those available by commercial immunoassay-based methods, for example, CEDIA or EMIT. Mass spectrometry-based methods are actually much better because you can target the drugs to your local population, what they're actually taking. You also don't have to confirm any positive immunoassays. But can a local hospital laboratory with limited staffing, limited experience in toxicology actually run a proper service? So you start then tailing towards a regional service which has got the necessary skills and expertise. But then can it actually offer tailored services to all the areas that it serves? So the changes to our screening patterns, which we're working on now, have been driven by the service users. So going out there, talking to the clinicians, finding out what the clients are saying to them, then targeting the screens to those drugs that are known to be out there, talking to public health, what are their concerns. The battle I've got, and I'm winning it, thankfully, at long last, the NHS, National Health Service in the UK, it can be quite hidebound. And so it takes a long time to learn the service management of relying on the immunoassays. They're easy to do. You stick them on a big main chemistry analyzer, you press go, and away you go. There are, of course, issues around staff training. Taking staff out in the main clinical chemistry lab, shift rotation, is problematical. We rely on rotating staff. There are issues there, obviously. So we got ourselves a nice shiny acute officer a couple of years ago, and I just thought I would illustrate this by two cases to show you the difference of what we can do with acute off and actually why it's made itself indispensable. So this was a few years ago. A person was admitted to an ITU in the region. The initial CEDIA screen was positive for benzodiazepines, but we couldn't find any trace of diazepam or its metabolites. They were positive for zopiclone and codeine. The clinicians, had gone to the patient's pockets and they'd found it produced as a tablet. We analysed it by the tandem. We'd already tuned up the tandem for phenazepam sometime prior to this, I think because I'd probably read in the literature that it was going to be an issue in the UK at the time. The tablet was found to contain phenazepam. And at the time, that was actually quite common in central Scotland, and we're not actually that far south of Scotland. And so things obviously drifted over the border. But there was no trace of the drug in the urine. Fortunately, we got lucky with a paper in the literature, and that's the Crichton paper I referred to below there. And we were able to use their settings for the tandem, and thankfully it worked. But as those of you who use mass spectrometry a lot will know it's not necessarily that you can use a tandem settings between different manufacturers or even different instruments from the same manufacturer. We picked up the 3-hydroxy metabolite in the urine, and we subsequently confirmed this with a certified reference material. But it was enough for the clinicians to be able to say, look, it's phenazepam. They will go over it, and we were able to give them some details of the pharmacokinetics of the drug. Now, flualprazolam. This is post the arrival of the QTOF. Okay, we received intelligence from public health that this drug was being used in the region. So all we did was imported the .mol file from ChemSpider. And for those of you who aren't aware of ChemSpider, it's a very useful resource produced by the Royal Society of Chemistry, and loads of chemicals on there. And you've got a little ring there around the little disk sign. Click on that, you get the mol file for that structure, which you can import directly into the software. Okay. You can also import the mol file into ChemSketch, a similar program, and then you can create .mol files for possible metabolites. You can just have fun sticking hydroxy groups on whatever you think is reasonable. So we got a blood sample. It was collected from an early adopter in the region who refused to give a urine sample. Okay. The clinicians have got suspicions about this person. He may actually, I think it's a he, may actually be a dealer. Anyway, so we simply ran it through the QTOF after a simple protein crash. Okay, the analyzer software, that's Unified, calculated the predicted M over Z of the molecule and can also inform in silico fragmentation to give you additional, certainty you've got it right. We picked up the flualprazolam in the blood. We then followed that up by a tablet that was helpfully sent to us by public health, and then identifying the flualprazolam, and then we could then follow it on and say, look, we're 95% certain the CRMs on order will confirm once we've got that, and we're bang on right. We're actually quite proud of ourselves for that one. We then obviously set up a confirmatory method in the tandem, so that we then got a screening method using the QTOF, and then we can confirm using the tandem should there be any doubt, or should that be needed by the powers that be. So the phenazepam case, using the tandem, we simply got lucky. There's no other word for it. We got lucky. Okay, and that was approximately 3 days' work, and it was edge of our, seat of edge of our pants, edge of the seat, or whatever case. So the flualprazolam was actually much easier. Result in the patient was out for the day, along with a tablet analysis, backed up with a confirmation with the CRM. We then were able to get much quicker warnings out to public health and the clinicians in the region, and public health were able to use that to alert clinicians to what was out there and what was happening. You don't have to wait for the CRMs to be available to tune up your mass spectrometer, and you also don't have to wait until a helpful paper appears in the literature, which of course could be at least a year after the event of the molecule appearing and somebody doing the metabolism studies. So that's basically all I have to say. So any questions? And just as you're thinking of your questions, I'd like to thank the staff from the lab, particularly Anne, who's my amazing deputy, who has led in developing the work with the QTOF into a useful clinical service, and as well as the work on the post-mortem service. I'd also like to thank public health in the region, particularly Teesside, for all the information they send us. And what's made us successful and made us useful to people is the fact that we operate as a multidisciplinary service with cooperation. Part of my job really is why I can't tell you much about the lab analysis is I spend the bulk of my life writing reports or talking to people to find out what they want, explain our findings, and it's actually very important and it's greatly appreciated. So thank you very much, and as again, any questions?